Welcome to the Padhai Karlo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is electric field lines, the visual tool physicists use to represent invisible electric fields, and the strict rules these diagrams must always follow. Let's begin. Electric field lines are genuinely imaginary lines, drawn so that the tangent to the line, at any point gives the direction of the electric field at that exact point, and the density or lines how closely packed they are, genuinely represents the field's relative strength. Closely spaced lines mean a strong field, widely spaced lines mean a weak field. Field lines genuinely always originate from positive charges and terminate on negative charges, or extend outward to infinity, if no matching negative charge is nearby for an isolated positive point charge. The lines radiate outward symmetrically in all directions, while for an isolated negative charge, they point inward toward it symmetrically, from all directions. Field lines genuinely can never cross each other. If two lines crossed at some point, that point would genuinely have two different directions for the electric field simultaneously, which is physically genuinely impossible, since the field at any given point must have exactly one single, well-defined direction. Field lines also genuinely never form closed loops in an electrostatic field, since that would imply doing net positive work on a charge moved all the way around the loop and back to its starting point, which would violate the fact that the electrostatic force is conservative. This specific property distinguishes static electric fields from the field lines or magnetic fields, which genuinely do form closed loops instead. Field lines also always emerge from, or arrive at, a conductor's surface genuinely perpendicular to that surface, since any component or the field parallel to a conducting surface would immediately drive charges to keep moving along that surface, which is inconsistent with electrostatic equilibrium. For a genuine electric dipole, two equal and opposite charges, field lines emerged from the positive charge and curve around to terminate on the negative charge, and the line density between them is genuinely much higher than the density far away, correctly showing the field is strongest in that specific region between the two charges. A frequently tested trap involves genuinely being given a field line diagram and asked to compare the field strength or the charge magnitude at different specific points. Remember that closer line spacing genuinely means a stronger field at that specific location. And for two different point charges shown with different numbers or lines, the ratio of the number or lines emerging from each is genuinely proportional to the ratio of their actual charge magnitudes. Also remember that for a genuinely uniform electric field, like between two oppositely charged parallel plates, the field lines are drawn as straight, parallel and genuinely equally spaced lines throughout, correctly indicating that the field strength stays constant everywhere in that specific region. Let's recap. Electric field lines show field direction via their tangent and field strength via their density, always originating from positive charges and ending on negative ones. They can never cross, never form closed loops in electrostatics, and always meet a conductor's surface perpendicularly. Reading, pose, P acting Muk parasign strength, and line count for charge magnitude, is the key skill this topic tests. That's electric field lines. Keep the never cross rule and the perpendicular to conductor rule sharp. They're the fastest way to spot an incorrect field line diagram on the exam. If this video helped, please like it and subscribe to Padhai Karlo for more content just like this. See Pierre Clois Thermal Pisa Hissing Paschimi Afriki Rendinavian Leonie next one.